The Royal Australian Navy plans to roll out the largest class of warship in its history. The Canberra-class warships, also known as LHDs, will be 230 metres long and 32 metres wide. The new LHDs will be required to transport and store army weaponry, including incendiary thermite grenades. Thermite grenades can burn through a quarter-inch of steel in 40 seconds. This is a huge problem, one which the Navy does not have a solution for.
At UQ Defence Systems Limited, we have been tasked by the Royal Australian Navy to prevent such a threat from occurring. The project team comprises of professionals with extensive background knowledge and experience in their chosen field. We have Jim Hadfield, Nirvan Maisuria, Braden Mewing, and myself, Wesley Watt.
The products of a thermite grenade burn create several problems. It is a highly exothermic reaction which generates extreme heat exuding from the molten metal mixture. Additionally, there is a high pressure, high temperature gas which is potentially poisonous. For the locker to be a success, it must mitigate these three issues from affecting the vessel and its crew. The design should ensure that the grenades are protected from environmental elements and impacts on board the vessel.
The project has been divided into 4 major parts. The major parts are as follows. Develop a detailed model of a thermite grenade deflagration. Study ammunition locker design principles, generate locker concepts, and select a best concept. Select materials capable of withstanding thermite grenade deflagrations, and study how to incorporate these into the locker concepts. And then finally, detailed design and analysis of the chosen locker concept.
Phase 1 of the project will result in the selection of a thermite grenade locker concept to carry forward into Phase 2. The justification for this decision will be communicated directly to the client in their critical design review presentation. The work involved in Phase 1 is expected to be completed no later than the 3rd of August 2015. If Phase 1 is successful, the project will progress to the next phase. Phase 2 of the project will result in the production of a detailed design of a thermite grenade locker and a proof of concept through finite element analysis. The detailed design and results of the FEA will be communicated to the client through the production of a final design report. The work involved in Phase 2 is expected to be completed no later than the 31st of October 2015. The successful completion of Phase 2 will signify the completion of the project.
I have taken on the role of project coordinator. This role involves determining which tasks to perform, assigning these tasks to other members of the team, and ensuring that the requirements of the client are fulfilled.
My role within the team is Client Liaison Officer. I'll handle the team's communication with the client and convey any concerns the client may have to the rest of the design team. In order to ensure the project runs smoothly, I'll arrange regular meetings with the client and maintain email correspondence.
My role within the team is Chief Design Engineer. I will conduct research on the products of the thermite grenade burn in order to establish the mechanical and thermal loads that will be encountered. However, my main task will be analyzing and reviewing the technical aspects of our proposed locker concepts. The motive of this is to validate the feasibility of each proposed design.
My role as Quality Assurance Officer involves managing team members and the work that they produce. I have to ensure that UQ Defence Systems outputs for the critical design review and the final report are completed at a professional standard which uses consistent language and formatting. In my role, I will be constantly interacting with other team members to ensure that they are meeting timelines and that any design concepts are communicated with clarity and precision. A part of my role is document management, for which I plan to utilise Google Drive to control the documents used throughout the project.
In my design role, once I've established the minimum thermal and structural loads the locker must meet, this information will be communicated to the rest of the team, so that specific properties of the proposed design concepts can be generated. From these design concepts, I will then construct a CAD model, so that structural and thermal finite element analysis can be performed. Through this process, our design can then be reviewed and further optimized into fulfilling the requirements of our client and in developing the best possible solution.
My primary role within this project is the research of materials and manufacture, as well as assisting in developing the final design in conjunction with the other team members. It is crucial that the design of the locker is able to withstand the extremely high temperatures and is able to contain the reaction and still be structurally sound. Material selection is extremely important, and as such, it is necessary to thoroughly research potential designs that utilize a range of ceramics, advanced composites, and metals. I will also be involved in the development of simulation and modelling, something crucial to the project as the means to manufacture and test our design are restrictive.
I am responsible for conducting research on current ammunition locker designs and generating locker concepts. I will eventually assist Wesley in producing a detailed design of a thermite grenade locker and conducting the relevant finite element analyses on the final design.
As the plant of the group, my design role is to investigate alternative technologies which may assist in forming the solution. I've looked at different design geometries in a bid to optimise the space occupied by the locker. This is one of the group's key performance indicators. I've investigated refractory sand compositions as a method of dissipating the heat from the molten metal, and I've considered automatic and manual jettisoning systems to instantly dispose of a burning grenade. Looking forward, I'll utilise this research to form the detailed design.
The safety of military personnel and the functionality of the vessel are both extremely vital in enabling the Navy to perform to a high standard in peace and wartime operations, domestically and globally. The significant threat posed by the unrestricted and uncontained ignition of a military thermite grenade could have potentially disastrous consequences, and as such, an effective solution is key to providing capability without compromising safety. UQ Defence Systems Limited will continue to work closely with the Royal Australian Navy to develop a product suitable for deployment, intending to meet or exceed the standards required.
Our team will ensure through innovation, critical analysis, and advanced modelling that the development of the thermite grenade locker results in a successful design and fosters an ongoing relationship with the Royal Australian Navy.